I can't hear you. Ma'am, can you hear me now? Uh, is
Yeah,
my voice?
now it's audible, Akshita. Yeah,
Yes.
it's a technical glitch, maybe. Not an
Yes.
issue. Fine, we'll work over that. Okay. And I'll
Oh,
inform ma'am that you need only one link for the thorough class system.
yes, ma'am.
Done. Let's move ahead with our next topic, and the topic is spring force. Okay.
Yes, ma'am.
This is what where we left yesterday.
Yes, ma'am.
And yeah, I had told you that the formula is F equals to minus kx. Okay.
Yes.
Now we have two types of spring forces.
Compress.
Very first one is
Con. That.
very
Compression.
yeah, not that compression
Oh,
and rarefaction you are saying, na?
yes, ma'am.
Yeah, but we can connect the springs in two ways. Do you remember that? Series connection and parallel connection of the spring.
For the spring, ma'am, series and
Yeah,
parallel.
yeah. Do you know
Uh,
this?
no, ma'am.
Oh, perfectly fine. But
I
it is there
thought.
in your syllabus. Yeah,
Okay.
say. Say,
I
say,
thought
say, say.
series and parallel were only in the electric thingy.
No, 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 no. Combination of spring is there in your syllabus, which is
Okay.
series and parallel. Done?
Yes,
Okay.
ma'am.
So let's do the combination of the spring. And when we have the series combination, basically like this. If suppose this is the fixed terminal where I'm connecting the spring, and here I have the next spring. Okay. Suppose here I'm connecting a mass, let's say M, which is drawing it with some force X, okay, and it's been dragging with the displacement of forces F. So this has been applied X2 displacement, this has been applied X1 displacement. Done. The constant K1, let's the constant is K2. Done. So here you will get the formula for this particular combination as 1 over Ke is equal to 1 over K1 plus 1 over K2. This is for series connection. Understood?
Yes, ma'am.
Let's go for the parallel connection now. In
For
parallel
parallel,
connection, what
like
happens is suppose,
case,
yeah, say,
so for parallel, it will be like Kp is equal to K1 plus K2 plus
yeah,
like.
exactly. So
Okay.
here, if suppose this is the spring 1, this is spring 2, okay. So these both are displacing with the same displacement x, but the force here is F1, force here is F2. Okay, let's the K1 if I calculate K1 is same in both. It has been told that they are carrying the same K. Or let us take different only. Let's take different only. Okay. So let's say mass M is here and it has been stretched with force F, and here it has been dragged with displacement X. So the formula will be equal to K1 plus K2. Done? So
Yes,
these
ma'am.
are the two formulas. Done? Need to be taken in mind here. X is same and F is different on both the objects. Done. Need to be taken care for this particular. This is a hashtag that you need to keep this in mind. Okay, for this particular thing. And for here,
Yes, ma'am.
your uh, F is same. Likewise here, X is same. So here F is same and your X is different. That is X1 plus X2. Okay. X equals to X1 plus X2. So this is different. Done? Understood? Any doubts? Shall we move ahead? Akshata, you are not replying.
Hello, ma'am. Can you hear me? Hello, ma'am.
Yes. Yeah, you are audible.
Yes,
You
ma'am.
are clearly audible to me. Sometimes your voice is going, maybe some technical glitch is there. Perfectly fine, but it's okay. Okay, I'm
Yes.
asking, did you understood or not?
Yes, ma'am. I said I understood, but connection lost. Podcast.
Okay, so last part I had told that during series connection F remains the same whereas X changes. In parallel connection X remains the same whereas F changes. Done?
Yes, ma'am.
Understood or not? Because see
Yes, ma'am.
here it is parallel, so they both will drive the same displacement, but the force applied on both of them will be somewhat different. Done? Whereas
Yes.
if here I talk about x1 and x2, both the combination will give you the final drag, that is x. Okay, whereas same mass is there, so it will apply same force on both the springs.
Yes, ma'am.
Okay, until and unless spring remains the same, tension remains the same. Understood? No?
Yes, ma'am.
Great. Now let's come to the next point, and that is observer and the frames. Okay, so if I have observer and if I have frames, then very first one is when the observer is standing where acceleration is 0 and v remains the constant. Done. This is known as inertial frame of reference. Done. And
Yes.
here all the laws, sorry, here all the laws of Newton remains valid.
Yes, ma'am.
Okay. Next of reference that we have is where the observer is also moving. That is, A is not equal to 0 and its velocity keeps on changing. Understood? So here, this is known as non-inertial frame of reference. Okay. And here all the Newton's laws of motion are not valid. Considered? Okay.
Yes.
Now let me give you one example. Okay. Just one example and we will move for the next question. Suppose this is the elevator and here is the tension T. Here I am tying a mass M with some mass weight mg and the tension is T. Done. This is going up with acceleration A. Okay. This elevator is going up.
Yes, ma'am.
Okay. A person is standing here and he is observing this particular motion happening with mass m. So what he will say? He will say that T minus mg is equal to ma. So ultimately his tension force will be G plus A. Correct?
Yes, ma'am.
It's going up, so acceleration direction is up. So T minus mg will be equal to the total force is T minus mg, which is equal to ma Newton's second law I had applied.
Yes, ma'am.
Okay. Done.
Yes, ma'am.
Next is suppose here I am suppose here I am making another elevator in which the mass is again hanging like this. Let's say mass m, and here I am having mg, here I am having tension T. Now the person is standing here. Okay, so this person B will say, as the elevator is going up, he will say that T equals to mg. Both are in equilibrium with each other.
Yes, ma'am.
Okay, as per
Yes.
Newton's law. Is it
Yes.
moving? No. Is
No,
it
ma'am.
moving? No. But when he is standing outside, is it moving? Yes. Is it? It's going up.
Yes, ma'am.
I hope I'm making you understand.
Yes, ma'am.
So when he is at rest, according to him, this is moving. But when he is also moving with the frame, that is, when he is in non-inertial frame, he is also moving the observer. So according to him, now this is at rest. Correct?
Yes, ma'am.
So hence T equals to mg. Whereas this answer is wrong. as per Newton's law. Okay. What happened is, as per Newton's law, that hold only for inertial. Okay, what is inertial, Akshita?
Only for inertial.
Huh.
Inertial, like the
What?
first law.
Huh. Inertial means when the observer is standing at rest and he is observing the things happening.
Then they both won't be like the same.
Which will not be same? Akshita?
There is a law with the term inertia.
First law of Newton, which says until unless you won't apply any external force, the object
There
don't
won't
starts
be
moving.
the object. Yes, ma'am.
Yeah,
It stays
stays in
same.
its inertia. Yeah. So
Okay, ma'am. Oh, in its inertia means, oh, yes, ma'am.
inertia means until unless you won't apply any force, the object will not move, will not leave its uniform motion position.
Yes, ma'am. Yes, ma'am.
Okay. But I am saying that Newton's law says that suppose when you are standing here, you observe this object is moving up. So you had told that T minus mg equals to ma,
Yes,
right?
ma'am.
Okay. So now we accept it. Yes, T equals to m plus g plus a. It is correct. But if suppose I am standing inside the elevator, as per me, this is at rest. Making sense?
Yes, ma'am.
That means Newton's first law. This is Newton's second law. So Newton's first law says what? At equilibrium, both the forces are equal to each other and hence the object is not moving. Am I
Yes,
making
ma'am.
sense? But T equals to mg. Is it correct? I'm
No,
asking, is
ma'am.
it correct? T equals to mg. No, it's not correct. Okay. The object itself is moving when you are standing inside. Why? How? That let me explain it to you now. Okay. So basically, Newton's laws were valid for non-inertial frame of reference, inertial frame of reference and non-inertial frame of reference. They were not valid.
Yes, ma'am.
Okay.
Yes, ma'am.
I hope I am making you understand. So I'm doing this
Yes.
terminology again, that when the mass is here and it is tied with tension T and it is having a mg mass over here, then at the same time, this is where it is happening when the elevator is here and the person is also standing inside, is moving with acceleration A. Right?
Yes, ma'am.
Okay. So this is non-inertial frame of reference. This is non-inertial. Why? Because the person is moving. Person is moving who is observing the activity. Are you getting my point?
Yes, ma'am.
Okay, so how you can correct it? You can correct it as M, here is the tension force, here is the mg force. Now you have to add one extra pseudo force which is acting in against of the action. Okay, that is
Yes,
in the
ma'am.
always opposite direction of the acceleration. Then now you will get your answers as correct. M G plus ma, so T equals to m G plus a. Now get this equation. Okay,
Yes, ma'am.
this particular equation and this particular equation have got same. Now is it correct? So we need
Yes.
to add one pseudo force when the person is in non-inertial frame of reference. Understood or not?
Yes, ma'am.
Okay, let me give you another example. A person is standing here and a person is standing here. They are playing this thing. Okay, as per this, when you are towards the center and rotating, that means you are along the radius velocity. You are being applied with centripetal force.
Yes, ma'am.
Correct?
Yes,
Which
ma'am.
is mv square over r. Okay, so I should write that this force is been applied with centripetal force. No, it has been balanced with centrifugal force. One more force comes in action, which is a pseudo force again. This is a pseudo force, okay, which is non-existing in the nature, but yeah, it acts when the person is in non-inertial frame of rotation. Okay, so whenever you are applied with centripetal force, that is towards the center, if this is my mass m, it is applying a force mv square over r, that is towards the center along the radius. At the same time, one normal force acts outward, which is known as centrifugal force, and it is having the same ability. Hence, that is why the person always feel like I will fall outward. Something is dragging him outward. Then only he will feel like that, no?
Yes, ma'am.
Making sense or not?
Yes, ma'am. Yes, ma'am.
Sure?
Sure, ma'am.
Okay. Now, after this, we are having frictional force. Okay. Frictional two type. Basically, it is the force which is applied when some object is in contact and it applies a opposing force to the relative motion of the two bodies, right?
Yes, ma'am.
Great. Now it is of two types. Very first one is static and the second one is kinetic. Okay. So the thing is, we have, suppose this is a slider, a person is standing here. This is static friction. A person is standing here just at the verge of getting slided. Now he is in the limiting friction. A person slides down, it is in the kinetic friction. Understood?
Yes, ma'am.
This is static friction.
Yes,
Any
ma'am.
doubts you are facing?
No, ma'am.
So this is limiting friction. This is kinetic friction. Okay.
Yes, ma'am.
Your frictional force does not have any formula. It will have the same formula as your normal force is having. Okay, I'll give you example. If suppose I have frictional force, then there is a thing that it will be applied to the normal thing which is happening in the nature, normal force. Done.
Yes.
Some normal force which has been applied over the object that will be directly proportional to the amount of friction. Okay, the more you drag any object, the more the friction you will find over that surface. Done. Now here, when I convert it into equal to symbol, this is mu r into n. Now what is mu r? Mu r is basically the coefficient of kinetic friction.
Yes,
Okay.
ma'am.
Okay.
Yes, ma'am.
So basically formula that you can apply is this. Okay. You have to be sure that what type of formula you are applying. I can give you one example. Suppose this is the surface and here I am keeping an object, let's say of 4 kg. Okay. So this is your normal force. This is your 4g which has been applied. Let's say it has been moving over here in this direction with 10 Newton force. Question is find the frictional force. In your exam, the question will be like, if I'm applying this much of force, will it move or will it not move? So you have to find out limiting friction coefficient. If it is greater than, then it will not move. If it is smaller than, then it will move with kinetic friction. Okay. I will show you these type of questions also. Don't worry. Okay.
Greater
Yeah.
than which? Greater than what, ma'am?
Limiting friction means the last verge where you feel like you are about to slide.
No, ma'am. You said like if we get a value, right? And if the value is greater than, there should be a specific number, right?
Yeah, the number is this. Number is this. coefficient of kinetic friction.
Okay, ma'am.
Okay.
Okay.
So when your coefficient that you are getting is more, then you will be at rest. But if it is less than this, then okay, kinetic friction is happening,
Yes, ma'am.
right?
Yes, ma'am.
When
Yes,
the
ma'am.
object will start moving, when your frictional force is greater than the force which has been applied over the object, or when it is less than the object.
When it's more than the object.
Yeah, exactly. Understood now how it works.
Yes. Yes, ma'am.
Great. So this is find frictional force. Let us do this. Okay. I am aware that my n equals to 4g, which is
Yes, ma'am.
nothing but 40 Newton. Correct? Okay.
Yes, ma'am.
I got my normal force. Now see how I will apply this over here. So my frictional force is mu r into n. Correct?
Yes, ma'am.
Then here let's say the mu r is given as 0.2. Mu coefficient does not have any SI unit. Okay.
Yes,
Akshita?
ma'am. Yes, ma'am.
Great. So that means my FR will be equal to 0.2 into 40, which is nothing but 8 newtons.
Yes, ma'am.
Agreed?
Yes, ma'am.
Any doubts?
No, ma'am. So they are giving the mu r the number in the question.
Yeah, I'm explaining you that. Don't worry. Now, this is all about kinetic friction. Are you facing any difficulty? Shall I give you one more question for this? Suppose here is the
Okay.
static surface. Here I have 4 kg of the object. Done. Here the mu are, let's say, 0.3. Okay. And it has been applied
Okay.
with a
So they have
force of,
already
let's say,
the mu r is given in the question. So we have to
given.
find specific
Yeah.
mu r.
No. I will explain you how they will ask. Don't worry. Okay. Yeah. So it is, let's say it is at 45 degree. Now what happens here is, okay. So let's draw the FBD for this. So this is the 4 kg of the mass. Okay. First thing, your arrow of the force vector should not be touching the object, but it should be away from the object. Okay. So that means we have to drag this force in this direction. I am doing parallel shift of this vector. Understood? So I have my 20 Newton over here. We can do that, right, Akshita?
Yes, ma'am.
Are you sure you are aware of parallel shift?
Yes, ma'am. In vectors.
Great. So, if it is here, so one up, one down. I got my forces. Okay. As the angle is here with the horizontal, so with the horizontal, it is 45 degree. Correct?
Yes, ma'am.
So this will be 20 cos 45 degree. This will be 20 sine 45 degree. Correct?
Yes, ma'am.
Here is the normal force. And here in against of the object will be the frictional force. Correct?
Yes, ma'am.
The object is moving in this side. Okay?
Okay.
So how I will do that? My normal force is 20 sine 45. Give me the answer. 20 sine 45 is how
Yes,
much?
ma'am.
Check your calculator. Be quick.
20 sine 45 is 14.1.
14.1 Newton. Done. Now after this, I will apply it in the formula that my frictional force is mu r into n. So what is mu r into n? Mu r is 0.3 and this is 14.1. Okay, now what should be the answer? Yeah,
202.23. 202.2.
202.2.
Yes, ma'am.
So that means it is 2.0 into 10 raised to 2. Correct? Newtons.
Yes, ma'am.
Done. Okay, now find out the acceleration. What is the acceleration? Acceleration means when suppose you are going in this direction. You are going in this direction, no? So this minus this will be your acceleration over F. F equals to ma. F
Yes,
equals
ma'am.
to ma. Acceleration is F over M. Am I
Yes,
going
ma'am.
correct? Okay, what is acceleration? Forward force minus backward force.
Yes, ma'am.
Correct? Okay, so it will be 20 cos 45 minus frictional force is how much? 202.2 over mass. Mass is how much? 4 kg. So divided by 4. This is your acceleration. Understood how I had done?
Yes, ma'am.
Any doubt still here, Akshita?
No, ma'am.
Sure.
Sure.
Okay. Now the next one is static friction. Pay attention what is static friction. So basically your static friction is nothing but when the F limiting, okay, is greater than
Yes.
F kinetic, then the object will not move.
Yes, ma'am.
Okay, because frictional force of motion and is less than the frictional force of limiting. Correct?
Yes, ma'am.
Okay. When does the body moves? So body moves only when
It is
your
great.
F applied is greater than maximum static or F limiting. Now you understood?
Yes, ma'am.
Any doubts?
No, ma'am.
This is a hashtag. You should note it down. In exam, it will help you out. So what is the formula for F limiting? The same one, the static friction constant multiply N. Okay.
Yes, ma'am.
There is no formula for F kinetic. If it is greater than, object is moving. If it is less than, object is not moving. When it is moving, that is the kinetic. Because you are aware, no, that how much soever you move in the forward direction, that much only the backward force will be applied in frictional case.
Yes. Yes, ma'am.
Right? Right or not, Akshita?
Yes, ma'am.
If you
Yes,
are
ma'am.
moving
Right.
with less velocity in the air, you will feel less air drag. But when you are moving with a very high velocity in the air drag, you will feel the very high opposing air drag force. Right?
Yes. Yes, ma'am. Yes, ma'am.
Okay. So there are only two formulas, F limiting and frictional force. Done?
Yes, ma'am.
Okay. Now listen very, very carefully. Suppose, yeah, I will explain that how the object is said to be not moving. Let me give you a question regarding that. Suppose here is a fixed state and here the object is placed, let's say of 4 kg. It is said to be applied with 20 Newton of the force and the static coefficient is 0.6, whereas the kinetic friction is said to be 0.4. Let's see, will it move or not? So we will apply the formula that F limiting is nothing but mu s into n. Correct?
Yes, ma'am.
Okay. So here is the normal force. Again, here is the 4g force, right? So I will
Yes,
apply
ma'am.
that my normal force is 40. Correct? It is 40. Isn't it?
Yes, ma'am.
Okay, great. So what is mu s? 0.6 multiply 40. What is the answer? 24 Newton. Correct?
Yes, ma'am.
What is the applied force?
20 Newton.
20
24 ma'am.
Newton. So my F applied is less than my F limiting. Hence the object will,
It's
tell
less.
me,
So it won't move.
it won't move. Now you
Yes, ma'am.
understood how you have to do.
Yes, ma'am.
Any doubt?
No, ma'am. So they will give the Newton for like uh the limiting force.
Yeah, obviously. Okay.
Okay.
Understood? Now any doubts in this?
No, ma'am.
Are you sure?
Sure, ma'am. Sure, ma'am.
Great. So now let's come to the air drag force. So air drag force is very easy. I guess it's not that much tough. Air drag is same as your frictional force,
Yes,
isn't
ma'am.
it? But it is in the fluid. Okay,
Yes.
it is in the fluid. So now after this, wait, just give me a second. Hmm. Are you able to understand everything?
Yes,
Anywhere
ma'am.
you are lagging?
No, ma'am.
Sure.
Sure, ma'am. Sure, ma'am. I can understand this. This
Okay.
is kind of easy than the other stuff.
Okay, good. Yeah, why I had explained all the forces, because it should not be like that you are not getting anything. Okay. So Newton's
Yes.
law and all this. Okay. Now let's come to the angular velocity and everything. Okay, that is the circular motion. Fine. So what is circular motion? This is not a very tough topic, but yeah, again, you need to understand what is the conversion we do over here. We convert from linear to circular. Okay, how do we convert? If suppose here we say displacement is here s, here the displacement is theta. So we call it as angular displacement. Here if the velocity is v, we call here angular velocity. Here the
Yes.
acceleration is a, we call it as angular acceleration. Now angular acceleration are of two types. They could be tangential and they could be centripetal.
Yes, ma'am.
Okay, this you need to understand. Okay, they could be tangential also. Tangential means understood, no? What along the circle if something is going like this.
Yes, ma'am.
This is tangential. Centripetal is when it is going towards the center and along the radius. Two types of
Yes, ma'am.
acceleration. Done? Okay. Now let's come to this. That if suppose this is my circle, I have started my journey from A point and I had traveled a distance, let's say till B point. So this is the displacement S. So I have reached from A point to B point. So this is my theta angle,
Yes, ma'am.
which I have covered. Okay. So in linear displacement, we walk. In angular displacement, we stand at the center.
How did the linear displacement come from the circular one, ma'am? Is it they
This is
both
what
are
I am explaining. Just a second, just a second. Okay. So what I was explaining is, suppose this is linear motion. Okay, this is linear motion. Now I'm changing my position to B, right? But what is angular motion? Suppose I'm standing at the center of the circle, but I am just moving my eyes from this angle to this angle. So I have moved from here to here. So this is my angle theta, angular motion that I had done.
yes,
Understood?
yes, ma'am.
When you are standing at the center and you are observing your field of view as 360-degree angle. So this will be your angular motion.
Yes,
Understood?
yes, ma'am.
Great. So now you are aware that the radius is r,
Yes, ma'am.
right? The radius is r. Yeah. Okay. So if I have r, I know that to find the angle, the formula is arc over radius. Correct?
Yes, ma'am.
Correct or not, Akshita?
Yes, ma'am.
Okay, to
Yes,
find
ma'am.
theta, the formula is, yeah, arc over radius. So arc is S, radius is R, this is theta. So that means my theta R equals to S. Understood? So I can
Yes,
connect my linear thing with my angular thing as S equals to theta times R. This is my first equation. Okay? Understood?
yes,
Now
ma'am.
velocity is S over T. So the angular velocity will be angular displacement over T.
Yes,
Understood?
ma'am. Yes, ma'am.
Okay, great. So that means if my total theta is, if my total theta is, let's say 2 pi, is it? Theta is 2 pi, no?
Yes, ma'am.
Okay, 2 pi over t, then the next formula for omega will be equals to 2 pi over t. Or 1 over t is also written as frequency. So the next formula that you will get it as 2 pi f. Understood for omega?
Yes,
Also,
ma'am.
like the first equation, I can say that my velocity equals to omega times r. So this is the connecting formula for linear and angular, and this is the actual formula for finding omega. Understood?
Yes, ma'am.
Okay, now let's come to the next pointer, and that is your acceleration. So basically, we are aware that acceleration is equal to change in velocity over change in time. Done. So this can also be written as what?
Change in velocity over change in time, WR by T.
WR by T. Yeah, WR by T is also correct. But can we write like, if I'm writing del V over del T, can I write it like, why the pen is finding difficulty in writing? Yeah. Okay. We can even write it as V delta theta over delta T.
Yes, ma'am. Yes, ma'am.
Check. Can we do this?
Delta V delta theta by delta T.
What is delta theta by delta T? V.
That V.
Yeah.
Yes, yes, ma'am.
Delta theta over delta T. Can we write it or not? Yeah. Because see,
Yes,
why I am
ma'am.
writing
Yes,
this, I am aware that my delta V is equal to V delta theta. Are you
yes,
aware
ma'am.
of this? Correct.
Yes, ma'am.
Now is it correct?
Yes, ma'am.
Okay. Okay. So basically here what is happening is I'm writing this particular thing in the place of this. That's it. I have changed nothing. Okay. Or even you can write it as V omega, because delta theta over delta t is omega.
Yes, ma'am.
Understood or not? Any
Yes, ma'am.
doubts?
No, ma'am.
Are you sure?
Yes, ma'am. I
Understood, no? Yeah.
second, ma'am. I'll just take a
Say.
1 second, ma'am.
Yeah. Take your time.
Okay, ma'am.
Okay?
You can just
Yeah. So now just listen. Yeah.
scroll
So if
a
I
bit.
apply the value of V,
Yes.
yeah, check. Check.
Okay, ma'am.
Done?
Yes,
Any
ma'am.
doubts, Akshita?
No, ma'am.
Sure?
Sure.
Great. So, yeah, when I apply the value of V equals to omega R over here, then I will get A equals to omega square R.
Yes, ma'am.
Correct? So the
Yes,
next
ma'am.
formula for acceleration is omega square R. Okay? Therefore, even I am aware that with this, my omega is what? A over V, and my omega is also equals to V over R.
Yes, ma'am.
Okay. I think
Yes,
the
ma'am.
response of screen time is going very low.
Yes,
Why
ma'am. I
it's not
can see the
responding?
lag.
Yeah, the lag is happening somewhere. Yeah, I was explaining equation 2. Equation 2 says V equals to omega R. So I can even write it as V over R. Right?
Yes, ma'am.
Okay, so if I apply it over here, then I will get E is equals to V square over R. Isn't it?
Yes, ma'am.
Any doubt still here?
No, ma'am.
Okay, so did you understood how to do?
Yes, ma'am. I think I
Let's
have to practice a bit of this part
uh
to
sure. Please do practice because it is definitely coming in the exam. Okay, like the wall of death is there, then the circular vertical motion is there. I will explain you a little bit part of that because that is very important for your exam. See, this is the vertical motion. This is suppose the mass. Here is the velocity. Okay, and here is your centripetal force. Right. So your
yes,
centripetal
ma'am.
force is nothing but mg force is also acting in the downward direction.
Yes, ma'am.
Okay, centripetal force is also acting. Okay, now if my ball is here, suppose, so here my centripetal force is acting and mg is acting over this side. Done. And in this direction the velocity is going right now, right? So when you talk about at the top, what is happening, that my mv square over r is equal to f top, correct?
Yes, ma'am.
And that is added with mg. Making sense?
Yes, ma'am.
Check. Correct? So my f top will be equal to mv square over r minus mg. Correct?
Yes, ma'am.
Now let's talk about at the bottom. At the bottom, what is happening?
F.
My mv square over r is equal to f bottom
Yes, ma'am.
minus mg. Correct?
Yes, ma'am.
Correct or not?
Yes,
So
ma'am.
my f bottom means I'm sorting this wala.
Yes, ma'am.
Okay. So this will be mv square over r plus mg. So in the bottom plus mg is there, at the top minus mg is there. Hence when you go up, you feel like somewhat has got less. When you come down,
Yes.
you feel like some weight has got added. Check both
Yes.
the situations.
Yes, ma'am.
What I am explaining is correct?
Yes, ma'am. It's correct.
Okay. Suppose I am having a depth of the well like this. Okay, like this. So here, if a person is standing, what type of forces are being applied over it? So the normal force is applied here. Your gravitational force is applied over here. Whereas your frictional force is applied over here in this direction. Hence the person does not move. Okay. And this is your radius of the death well. Understood?
Yes, ma'am.
Any doubts?
No, ma'am.
Sure.
No.
Okay, great. So now let's come to the next pointer, and that is just one second. Yeah. Okay, yeah. The next pointer is the types of work that we do. Okay. So work is what? Product of force multiply displacement. Okay.
Yes, ma'am.
Any doubts? And that
No,
is
ma'am.
in the direction of force. Displacement moved in the direction of force. So in the direction of higher force only you will see the work done happening. Done?
Yes, ma'am.
Great. Now after this we have the types of work. So there are positive work done. When do we get the positive work done? The formula is F dot delta S. Okay, cos theta. This is the formula. So when your theta is less than 90 degree, okay, then your cos theta is set to be positive, and hence the work done is also positive.
Yes, ma'am.
Understood? I'll give you one example. Suppose here I am trying to push my object. Let's say delta S. I am having here the toy car. Okay, and I'm applying a force over here. So it will move with a theta angle. Theta is less than 90. So the
Yes,
work
ma'am.
is happening.
So it will be
Okay, it
positive.
will be a positive work. Understood?
Yes, ma'am.
Because in the first quadrant cos theta is positive.
Yes, ma'am.
Correct? And
Yes, ma'am.
cos 0 is 1 and cos 90 is
1.
0. Cos 0 degree is 1.
Yes, ma'am.
Cos 90 degree is 0. Aware of this fact?
Yes, ma'am.
Okay, so if I apply it in F dot delta as cos theta, so if I make it cos 0, so it will be F dot delta S only. If I make it cos 0 degree,
Yes, ma'am.
then it will be 1. Hence it will be F dot delta S. So here you will get the maximum work.
Yes, ma'am.
Understood? But if you apply this formula, that force where you are applying is opposite is at 90 degree direction, then this term will completely become 0. So that means no work done.
Yes, ma'am.
Okay.
Yes, ma'am.
Example is, suppose this is a staircase and a person is walking and he had holded the pile of books over his head. So when he is moving in this direction, whereas the weight is applied in the downward direction. So here I got a 90 degree angle. So as the weight load of the book is doing no work while it's walk.
Yes, ma'am. So the work done is 0.
Yeah.
Yeah.
Work done by the books. Okay. Due to
Yes.
the load of the books. So I told you the next term, that is this one is the first. When do we have the positive work done? Now let's come to the second pointer. And this is also I had told that when theta equals to 90 degree, your work done will become 0. Done. Third pointer is when your theta is
Yes.
greater than 90 degree, your cos theta is negative and hence your work done will also be negative. Okay.
Yes, ma'am.
Akshita, any doubts?
No, ma'am.
Sure.
Yes, ma'am.
Because in
Sure,
the
ma'am.
second quadrant, cos theta is negative. Okay, like I can give you example. This is my door. I had tried to turn it in this direction, but again it got closed due to the presence of jacks. So it is going opposite to my work done. So this will be completely a negative work done. Understood?
Yes, ma'am.
Akshita, I'm trying to open my
Yes,
door in this direction, but it again got
yes,
closed in this
downward.
direction.
Yes, ma'am.
Yeah. So basically what is happening is I am trying to put it at 180 degree work.
Yes, ma'am.
Right? This is 180 degree
Like
angle.
in the quadrants.
I'm trying to open my door. Yeah, I'm trying to open my door, but it again got closed. Why did it got
Yes,
closed?
ma'am.
Because the force was acting like that. The jack was attached with the door and it is behaving like that. Okay, Akshita.
Yes, ma'am.
Any doubts?
No, ma'am.
Sure?
Yes, ma'am. Sure, ma'am.
Okay, very good. So basically, this is called work done. Now, when we draw the graph for F over delta x, just pay attention. When I draw the graph of F dot delta x, then the area under this is the work done.
Graph is momentum.
This will come in.
Oh.
Yeah, this is F and this is delta x. This type of question will come in your exam, so you have to keep this in mind that the area is the work done. Okay.
Yes. Yes, ma'am.
Great. Now, I'm aware that my force is also equal to, as suppose they give you this type of tricky question in Hooke's law. Hooke's law graph is something like this. Correct? Here is the
Yes.
K value. This is F value. This is delta X value. Correct?
Yes, ma'am.
Okay. So I'm aware that my F is equal to Kx. Right?
Yes, ma'am.
Right? And your work done is nothing but the energy supplied, right? So what is
Yes.
the energy supplied? Energy supplied is minus half kx square or minus half fx. So you can
Yes.
find this thing also.
Yes, ma'am.
Okay?
Yes, ma'am.
You are aware, no? Work done is energy
Oh,
because both
yes,
are
ma'am.
having the same SI units.
Yes, ma'am.
Okay. Any doubts still here?
No, ma'am.
Great. Now we are having the topic energy after this. So we are having different types of energy. What are the different types of energy? First is the potential energy. Potential energy again is of two types. Elastic potential energy and gravitational potential energy. Right?
Yes, ma'am.
Akshita, any doubts if you are facing? Just do let me know. Okay?
No, ma'am.
Great. So potential energy and gravitational potential energy. Then we have kinetic energy, right? I will
Yes, ma'am.
go one by one over these topics. Let's cover the very first topic. What is energy?
Yes,
Okay.
ma'am.
So I guess energy is nothing but ability to do work.
Yes, ma'am.
Okay. So ability to do work is known as energy. SI unit is joules. Okay. And it is a scalar quantity. Energy does not have any direction. Understood?
Yes, ma'am.
Okay, let's come to the first part, that is potential energy. So, what is potential energy? Basically, the energy possessed the screen response time is going very low. Yeah, the energy possessed by any object due to its position, shape, and size is known as potential energy. Okay,
Yes, ma'am.
good. So now basically what happens is potential energy could be of two type: gravitational potential energy. Gravitational potential energy is due to position. Okay, I'm explaining you only this thing now. So what happens is, suppose here I have a wall, okay, and here I am keeping a particular brick over this, and I am keeping a ball over it. Okay, it is trying to fall with a g acceleration due to gravity. Okay, and it is covering a height of h. So what is the formula for work done? It is F dot
Yes.
delta s. Yeah,
Oh,
what is F dot delta s? Ma. What is delta s over here is h, right?
yes, ma'am.
Due to the gravity factor, I got that a can be converted into g.
Yes, ma'am. So it will be
Correct?
mg.
So
Yes, ma'am.
hence potential energy formula is mgh. Making
Yes, ma'am.
sense? Any doubts?
No, ma'am.
Are you sure?
Yes, ma'am.
Okay, that's so great of you, Akshata. Till here, I had explained many terms, many forces to you. You need
Yes.
to practice it for sure. You need to practice it. Okay, if you leave it in between somewhere, it will not work that I am explaining you, and it will all go in vain. So, I had started it from here. Okay, and just do let me know if you are facing any doubts. Okay, this we had covered yesterday, but today I had covered from here. So we had
Yes.
discussed the series and parallel, then we had discussed the frame of reference. This will help you in fourth chapter. I had given you the intro of your fifth chapter, sorry, for A5. This is A5 chapter, okay,
Okay, ma'am.
of your A unit. Yeah, they will explain you inertial and non-inertial frame of reference, but still I had given one intro so that you can understand this thing in these motions also. Okay, so
Yes.
after that, centripetal and centrifugal, did you find any difficulty in these two forces?
Maybe a little bit, ma'am, but I think I need to practice it to feel if it's really difficult or if it just looks difficult.
Oh yeah, that makes sense. So
Yes,
you
ma'am.
need to practice this.
Yes, ma'am.
Okay,
I will send
so
you mail ID in the chat. Can you add like my mail to this notes?
uh, see, it becomes very tough for me to yeah. You had sent me your mail ID. I got it. Okay. So basically, see, what is the issue is, if you send it to me via mail now, it may be a possibility that I will not check because I'm going for school and then I'm returning back. Then starting from your class only, I'm taking the class. You are conducting the class at 5:30 and 6:30 only, no? Most
Yes,
probably.
ma'am. Yes,
So
ma'am.
barely it could happen that I had seen. Maybe it may be a chance. Yeah, I will take a look, but it may happen on any day that I am not observing. So better option, you send it to Miss Sonia and she will convey that to me directly.
Okay.
That would
Yes.
be a better option. Okay. Because see, she
Yes.
is in my direct contact. So to look over the laptop again and again becomes a little bit a tough task for me. Okay. So you can send her the WhatsApp, the clips that you are facing the difficulty, or the, I should say, the snapshots of the questions. She will send it to me directly and I will solve them. Okay.
Okay, ma'am.
Bye, Nakshita. Bye. Have a nice day.
Bye, ma'am. Thank you, ma'am.
Bye.